second question in the homework. We have a beam and we would like to draw normal axial force, shear force, and bending moment diagram. First step, please do your reaction calculation well. We have one reaction at this roller. The problem will mention what type of supports. Don't worry about this point, but please read the problem carefully. We have two reactions, YB and XB. Summation f of x equals 0. XB will be 0. Guys, remember I told you before, when you are solving this kind of problem, please don't write anything below the beam. Just do your calculations on the left side. Summation f of y equals 0. We have YA plus YB minus 6 minus 8 equals 0. So YA plus YB equal 14. Third equilibrium equation, summation moment at any point equals 0. I highly recommend to take moment at B, assume this direction is positive. Summation moment at B, so XB times 0. It's a force, need distance. YB is a force, need distance. The distance is 0, it's okay. And we have at B a moment which is negative, 6. But this 6 is moment, does not need distance. So I didn't multiply it by 0. Plus 8 times 2 plus 6 times 8. This 8 times this 2, this 6 times this total distance 8 equals 0. This part will be cancelled. The only unknown is y. Is what? Sorry, I forget something. I am done with 6, 8, but I missed YA. So we have negative YA, I'm sorry, times 4 equals 0. The only unknown in this equation is YA. So YA will be, I don't have a calculator. I'm sorry. 16 plus 48 divide 4. So we have 4, we have 12, 16. If you go back and put YA 16, value of YB will be negative 2. Is it correct? Guys, I'm sorry, I don't have a calculator right now, so can you help me? The value of YA here will be 16. No, I don't think so. I think no. So we have 16 plus 48 minus 6. So it will be 58 divide 4. So it will be 14.5. I'm sorry. So if you put YA 14.5, YB will be negative 0.5. Any recommendation? Thank you. Thank you. So YB is negative. What does it mean? Please put the right direction before starting to draw anything. YB is negative means the direction is down. 0.5. YA is positive 14.5. So the same direction equal 14.5. 0.5. Vertical lines. Three copies from the beam. Normal force diagram, shear force diagram, bending moment diagram. For normal, it's a piece of cake. You need to ask yourself one question. I'm gonna start from left. Here is the left support. Here is the left side. Do you have any force parallel to this beam? Do you have any force in this beam? Do you have any force in this beam parallel to this member? We have only xb, and the value of xb is 0, so normal force will be 0. For shear force diagram, I'm gonna go up if the force going up. I'm gonna go down if the force going down. We have 6 going down, constant. We have YA coming up, 14.5, so I will reach 8.5. Keep walking until you hit 8. Going down, how much? 8. So I will reach 2.5. Keep walking until you hit the last reaction, which is going down. The right direction is going down, 0.5. So I will go down 0.5 to reach 0. Negative, positive. To draw bending moment, I'm gonna start from left. If you have free end or hinge or roller, in other word, we don't have any concentrated moment. We don't have something like this. So your moment at the beginning will be 0. I need to figure out the value here. I need to figure out the value here. I need to figure out the value here. So M1 is 0. What is the value of M2, M3, M4? We have a technique. M2 equal. Previous value for M2 is M1, 0. Area of shear between the 2 points, 1 and 2. We have this negative area. Negative 6 time, 6 is this value, time this length equal 4. Your value will be negative 24. Negative means down. Next value, M3 equal previous value, M2, negative 24, plus area of shear between the 2 points. We have this rectangle, which is positive, 8.5 times this length 2. So the value will be 7. Negative 7. Negative means down. M4 equal previous value, negative 7, plus area of shear between the 2 points is positive. This area, this little area, 0.5 times 2. Your value will be negative 6. So the value here will be negative 6. From 6 to 7, from 7 to 24, from 24 to 0, I'm gonna draw lines. Connect between these values by lines. This diagram can be called bending moment diagram. Guys, in the exam, probably this problem will have 15 points. Probably. 5 point, I'm sorry, 20 point, 20. 5 point for reaction, 5 point for normal, 5 point for shear, 5 point for bending moment. So make sure you are doing your reactions well, in more details. More details. Just to write 0, if your normal force diagram is 0, you can get 5 points. For shear force diagram, which is going up and going down, another 5 points. For bending moment, another 5 points. If you have a little mistake, I will subtract 1 point, 2 points. Okay? So try to gain points. Any question? Do you have any question right now? Second question, I'm gonna go through distributed load because I know distributed load is confused a little bit. Let's start to do this one. This beam is fixed at A. So we have 3 reactions, YA, XA, and MA. Guys, before starting to do the reactions, you have uniform distributed load. I need to figure out the equivalent value. This equivalent value, how much? 2 times 10. The given value for the distributed load, 2 kb per foot, times the total length, 10 feet. So this equivalent value will be 20 kibs. Then go ahead and start. Yes, Mitchell. Before starting to draw diagrams, you have to put the right direction before drawing. Once you put the right directions, your values became all of them positive. So I'm gonna apply summation f of x equals 0, xa will be 0. Summation f of y equals 0, ya equal 20. Summation moment at A equals 0. Assume this direction is positive. I believe MA will be 100 kb foot. So, guys, please make sure you got positive value for XA, positive value for YA, positive value for MA. That means you assume the correct direction. So this one is 20, this one is 0, this one is 100. Vertical lines, vertical lines, vertical lines. I have 3 copies. Normal force diagram, shear force diagram, bending moment diagram. Do you have any force? Do you have any force parallel to this beam? XA, how much? 0. Your normal is 0. Shear, I'm gonna start from left. I will go up if the force goes up. I will go down if the force going down. Guys, please, everybody, pay attention. Everybody, please pay attention. At left, do you have any force going up or down? I am here. I am at the left end. Do you have any force going up or down? No, I don't have any force. So one of you will say, hey, we have the uniform distributed. No, I'm talking right now about this equivalent, 20. Please forget the distributed load. This equivalent to force is right now at this end? No. So do you have any force at this end? No. So I will not go up or down. Your value is 0. Walk. I will walk horizontally. But I will walk dashed line. Why? Because I'm walking inside distributed load. This point is very important. Please pay attention. Do you have any force, any ready force, or given force, or reaction, or any force? Force means something like this or something like this, up or down. Do you have any force like this at this end? No, your value is 0. So your value is 0, keep walking. I will walk horizontal, but I'm walking inside distributed load, so I will walk dashed. Keep walking until you hit the equivalent value 20. Going down, so I will go down 20. Dotted, dashed. You're still walking inside distributed load. Keep walking to the end of the distributed load. You have 20 here. What do you have at the end? We have a reaction YA, how much? 20. Going up, so I will go up to 0. Guys, do you remember what should I do at the end? From the first point of the dashed line to the end point of the dashed line, I have to draw a solid line. Negative. Bending moment. I will start from left. Guys, for any distributed load, if you have distributed load and you are talking about moment, I will stop at the beginning and the end only. This end and this end. I will not stop at the equivalent value. No, don't stop here for bending moment. So I need only to figure out this value and this value. That's it. The first value is 0. Your value here is 0. This end is free end. So I need to figure out the value here. Your value at the end equal previous value, which is 0, plus area of shear between the 2 points. Do you have any shear in between this point and this point? Yes. We have this negative area. Negative, it's triangle. 1/2 time 10, the total length, time this distance, this value is 20. So your value will be negative 100. Negative means down. 100. I have to connect between this value, which is 100, and this value, which is 0, by a parabola. Concave up. Your parabola will be like this. Any question? Any question? If you watched my recorded video for Friday, you should learn what should I do if you have uniform distributed load. Okay, that's fine. Aaron, you didn't watch my video, looks like, because I covered these topics. What should I do if you have uniform distributed load in the recorded video for Friday? But that's fine. We are doing homework to do mistakes, to avoid these mistakes in the exam. That's fine. Anthony, I cannot figure out what is your question. Is it okay if we cut the lens in half already? I'm not sure what you mean, but we don't need to make any cut. We need to draw a diagram. For bending moment, we need to stop at the beginning of the distributed load and the end of the distributed load. That's it. No. For bending moment, please don't try to stop at this value. Don't try. It's you are wasting your time. Please stop at the beginning and the end. I will not say it's wrong, but I don't like to ask you to stop here because you will waste some time to figure out this value. That's fine. If you stop here, you can figure out the value here and another value, so you can draw a curve and another curve. That's fine. But don't do this. You don't need, in this course at least. Okay? It's not wrong. It's not wrong, but I recommend to don't waste your time just at the beginning and the end. That's it. The last one is a piece of cake. You can figure out the reaction. I think this reaction will be 8 and this reaction will be 0. This horizontal reaction will be 0. So if you draw 3 copies for normal, shear, and moment, your normal force will be 0. For shear, I will start from left. I will go down 4. Keep walking. You have 8 going up, so I will go up to another 4. Keep walking. I will go down to 0. Please keep walking to the end of the beam. Negative, positive. For bending moment diagram, this value will be 0. The value here will be negative 16. The value here will be 0. The value here will be 0. So I will connect from 0 to 16, from 16 to 0, from 0 to 0. Here is the bending moment diagram.